Afternoon, wherever you are. Thank you for coming to this 2 hours workshop full of hands-on, where we will explain you how to build the Spring Pet Clinic sample application using, well, Spring and Apache Cassandra. So before even starting, can you put on the chat if you hear us properly, please? Oh, a word just to see if you sound good on the chat.
Sure. Hello, everybody. Welcome, welcome. This is my first workshop at DataStax with the DataStax developers, and so amazing to be with Cedric. So thank you, and I'm excited. So yeah.
Okay, all right. So a good check is okay. Let's move on. We do have a lot of stuff to cover. So I'm Cedric Lunven, and I'm leading the developer advocacy team at DataStax. I'm doing mostly Cassandra, Java, and Spring. What a coincidence. Pretty good for today. You've saw me a lot of time on this channel, but you know, today with me for the very first time, Mary is with us. So can you introduce yourself, please, Mary?
My name is Mary Grigleski. I am, as you can see over here, I'm primarily a Java person, but I also do other languages too. So I'm also the Java champion and also Chicago Java Users Group president, and I do Pulsar right now, streaming at DataStax. So really excited to be joining DataStax and the team, and just the energy is just what really, I love it here. So really an honor for me to be here. Thank you again. So this is a very quick intro about myself. So yeah.
This is great. Speaking of the team, you know, as always, it's not only 2 people on screen, 2 moving heads. We do have a full team helping, building the content, testing all the hands-on for you to succeed. So here is a team on screen. It's distributed as Cassandra across the world. And today in the chat, you will find Stefano helping, okay? But we will also keep an eye on the chat to help you if you get any trouble. Speaking of which, a little bit of our YouTube and Twitch. We monitor the chat on YouTube, mostly answering the question live. You can also ask your question on Discord on the channel workshop chat. And it's pretty convenient because when the stream, which is recorded on YouTube and will be available at same link, when this stream ends, you can still ask us questions in Discord using workshop chat. So please go there, subscribe. Also, we do have some micro in the YouTube chat using something called Nightbot. So by using exclamation mark and the code, you will get access to a link. So first 2 links for you to know: exclamation mark Discord to get the Discord registration link, and exclamation mark Menti to go to menti.com and play games with us. It will be an interactive session, just not a webinar. You will do the exercise. We will ask you a question. We will play a game. And if you answer fast, you will get some swag in the end. Full of hands-on, you will have to work, but you don't have to install anything. You know, for the experience to be as smooth as possible, everything is web-based. The database will be software as a service. The IDE development environment will be Gitpod, which is VS Code in the cloud with all the plugins you need. Everything will be installed for you. Those tools are free, so even if the workshop is ending or you are watching a recording right now, you can still use it. If you cannot use the macro, all the links are also in the description on the video. All right. If you complete the hands-on, do the exercises with us, even if it's after the session, and probably it will be after the session because we will need to move fast to stay in the 2 hours. You can upload the working app on a form, answering a few questions, and you will get redeemed this nice badge. So we are doing a workshop for 2 years, multiple hundreds of workshops happening now. And covering a wide range of topics. So here is a subset. I think now we do have 23 different badges. And today it will be a reactive Spring workshop. So working with Java, Spring, and we will build the schedule appointment application, which is Pet Clinic. Okay. I told you we will play some games and we will ask you questions. So you know what, without waiting more time, we can start immediately and see if these things working. And I will ask you a few super easy questions, not tricky, just to know you a little bit. So now open a new tab in your browser, go to menti.com, enter the screen that you can see on screen. You can also see the code that is now shown on the YouTube chat. Challenge just to know you a bit more. And at any time, I'm Menti, if you miss the code that I'm showing right now, or my head is just in front of the code that screen, go to menti.com and use the code. Here is the code. Okay, I can even, copy that code in the YouTube chat for everybody to copy paste it, because why not? Here is the code. So I see almost 100 people in the YouTube live and only 30 putting some hearts in Menti. So I could wait just 1 more minute, but because there is no challenge, I will keep moving. We need to keep this live with full of energy.
That's right.
Look at that. So I see 50 people now. So yeah. People keep coming, keep cooking. Soon we will have the quorum, the majority, so we can proceed. Keep moving, keep moving. Okay, anyway, you can catch up. As I told you, really no stress. The questions are really just to know you a little bit more. So welcome to this Spring Pet Clinic workshop. And my first question for you is simply, where are you from? So pick your location in the picture that I show you, just to see where are you coming from. Who are on YouTube late, who wake up early in the morning to be with us. We try to spot a time frame where you can have as many people as possible. And look at this map. We do have people from America up to Asia. Look at how we are distributed. Isn't that cool?
That is so amazing. So amazing. I love it. So
yeah, and as you can see, India is always super active, super involved with our sessions. So thank you for that. I know it might be a bit late. So yeah, we will try to stay in the 2 hours, just a little bit more eventually. But yeah, I know it's late for you. So again, thank you for joining. Yeah. All right. My second question for you is, how much experience do you have with Spring Framework? Because it will be a Spring session. You don't need to be an expert, but if you never heard about it, we should say a word about it. So Spring Framework is, I would say, the most in use Java framework out there right now, and you can use it for a lot of things. We will show you. But today we will use it as the runtime and also the multiple components that work together. Yeah, not too much spoiler. You will get it. So know the concept already, using regularly. Even if you use it regularly, I hope you will learn something today. So the second part will be Apache Cassandra. So how much experience do you have with Apache Cassandra? The application we develop or we will show you is an existing application for ages in the Spring world, but it was designed for a relational database like Oracle, Postgre, MySQL, and we change it to reflect the Cassandra. Okay, so not a lot know about Cassandra. Okay, you in the good place. Okay, this YouTube channel is all dedicated to share our love on the Cassandra NoSQL databases. So of course, I do have a couple of slides to explain you why you should consider to use it. Okay, right, keep moving. This is my last question. So I told you in 2 years, we've workshop every single weeks, sometimes multiple time a week. So yeah, we could have some returning people. If it's the first time, welcome, welcome, welcome. Hope you will enjoy the experience, the interactivity, my stupid accent, and the energy, and keep coming back every weeks.
Yeah.
All right. Okay. So a lot of newcomers. So yeah, take a seat, relax, enjoy, and yeah, you will learn a lot. That's my promise for you today. Okay. Keep this tab open. We will reuse this tab later when we will play a game all together. This is where you can win some swag box if you want to fast. But for now, go back to the slide and keep moving. We are in for 10 minutes, perfect timing to start working, right? All right, so that's the agenda for today. Some word about the pet clinic application itself, then how to build the application layer after layer, starting by the database up to the user interface, okay? So databases, connect to the databases, how to implement a service on top of the data service using some reactive technology, Spring Wake Flux with the reactive APIs, if you wish, creating some APIs as reactive, and then the game. All right, let's get rolling. Okay, so the pet clinic is the reference sample application in the Spring world. It's referenced, as the name stated, a pet clinic. So you will have veterinarian, owners of pets, and you will take some appointments for the pets. So here you got the link of the official project. Yeah, there for 15 years, but was only working with SQL. To make this community bigger, some people created the pet clinic community, and now you have multiple implementation of the same application, pet clinic, some Angular, some React, and multiple backend. So backend using the standard Spring REST, or using Spring Reactive like today, using a relational database, using other form of database. It's like, hey, I want to show you my technology with always the same sample. But of course, you want to know what it looked like. So I will show you a demo. You can also go to the demo. It's available. It's a live demo. You got the live demo link in the YouTube description. I think I put that as the first link. But here I will use my home over here. So that's the home page. So what you can see here is a list of veterinarian over here. You can edit, you can delete. Here you can define the type of pets. So here, I don't know, if you want to adopt a giraffe, you can add here a giraffe. It will show up. And you can also see the different owners and get the information regarding the owners. You can add a new pet. It's, create, read, update, delete application. And of course, this app will run in your laptop before the end of these 2 hours. That's my promise for you. My second one, first, you will learn a lot. Second, you will have that running on your machine in 2 hours, okay? So this is exactly what we will do. I think just you can play by yourself and see how it works. Okay. All right. So this is what we want to do. How do we do? Well, if you ask someone what your application look like, the architecture diagram could be this one, where you show multiple layers: the data layer, database, application tier layer, or backend, where you expose the backend services. When you do a full stack application in the JavaScript or front-end world, you think about two modules, the backend and the front end. So as of today, the front end will be Angular and the back end will be Spring Boot, and everything that I showed you. Okay, nothing to install. So the database will be Cassandra in the cloud using a service called ASTRA, and both the back end and the front end will run in your cloud-based IDE, which is called Gitpod. And my demo I just saw you was running in Gitpod. Okay, I told you we will start with the data and move one layer after the others to be able to build that application or run that application. So first, Apache Cassandra in a nutshell. So Apache Cassandra has been created in 2008 by two Facebook engineers. It's a NoSQL distributed database. You can install that product on a single machine, on the single machine, single server. This is what we call a node. And you can expect about 2 to 4 terabytes per installation and thousands of transactions per second, okay, and per thread. But it's a distributed database. So you want to install Cassandra on multiple machines, multiple nodes. In this architecture, there is no master. All nodes communicate to each other using a peer-to-peer algorithm, which is called the gossiping. Those nodes are grouped logically in something called a data center or a ring. So sometimes I will talk about the ring, sometimes I will talk about the data center. Okay, so both are exactly the same. I prefer use the term ring. Sometimes if you talk too much about data centers, people can get confused and think about the infrastructures building. Okay, so let's talk about the ring. So multiple nodes organized as the ring, no master. Created by Facebook and using by the biggest company in the world. So here you got a link, Cassandra, Netflix. I mean, this video, you should have a look there. That's the tech lead from Netflix coming here on this channel, explaining like 98% of the streaming data at Netflix are stored in Cassandra. Isn't that cool? And they gave you an idea of the size of their rings. Look at that, they do have. So 160,000 installation, 160,000 nodes at Apple, and Apple is not even the biggest user of Cassandra. They are even biggest user in Asia, but you can think about the big names, but they do not want really us to disclose the size. Okay, millions of operations per second, so very, very performant. Okay, so you can really scale as much as you want. The scalability is linear. If you need more capacity, more throughput, simply add new nodes. And here some big cool terms. So big data ready, read and write, super fast, linear scalability, high availability, self-healing, and vendor independent. Okay, so quickly, it's an Apache project. So there is no risk for the license to change. Lately some databases decided to change the license to protect themselves against the cloud providers. I can understand that. The Cassandra will not change. And so it's Apache and will stay Apache. Pretty cool, vendor independent. Each Cassandra node is performant and is the same as the others. Because there is no master, you can lose any of the node. It's not a big deal. The data is distributed across all the nodes, but is also replicated. The same data is available on multiple nodes. So if one node goes down, not a big deal. The data is still somewhere else. You can have your Cassandra cluster. So this time I talk about cluster with multiple rings. Isn't that cool? So you have installed multiple server as a ring, in a region, and you can install multiple rings across the world. And when you read or write from somewhere, the data will be replicated on the other rings by Cassandra itself. There is nothing to build, no batch. It's done by Cassandra itself. You need to have the network open, okay? But it's not master slave again. All the here called DC data center or rings are active. So you can read and write from everywhere, and it's working. It's self-healing. I can move quickly. Just appreciate altogether the GIF. You know, all my childhood. So now you know I'm old. Yeah, but so you can lose any of the node, any of the machine, and because the data is replicated, you will still get access to your data. And if the node goes back online, the remaining node will stream the guy what he can have missed as data for him to catch up. So he's self-healing. Okay. Vendor locking is also platform agnostic. You can install that wherever you like. Okay, it's open source, right? And you could have one ring in each cloud provider if you wish. Just open the network, and you can have the same data layer across multiple platforms, right? Technically, it's completely possible. Okay. So hope you enjoy or get this first grasp of what is Cassandra, why it's cool. And now it will be your turn to start a 3-node ring. I told you I do not want you to install anything, so we will use a software as a service. Okay, so the tool is called ASTRA. ASTRA DB for the database part of ASTRA. And as you can see, it's free to use, no credit card, and you can go up to multiple million read and write per month, and you will not get charged anything. So it will be free for you today. It will be free for you as long as you do not reach a threshold, and then you become a paid customer. And of course, to pay for the capacity, you get charged. But it could be used for super random use case if you are a student, if you want to test stuff, if you want these for a test environment, integration environment. That's pretty cool to use. Okay. Okay. And I saw that Namtram already used the micro ! Astra to get the link to go to Astra. Or here you see also ! GitHub. Okay, so what is cool with this framework workshop, to be honest, let me close that and delete this. I don't need anymore. It was my demo. Close. So here is the GitHub. In GitHub, you find all the source code needed. Okay, here you got all the source code, front end, back end, and you got a README over here where all the instructions are written step by step. I will be lazy in front of you. I will follow those steps. And you can do the same at home on your own pace if eventually I'm moving too fast. And here it is. So what we want: the objective, frequent ask question, material for the session. The slide I'm using are also there as a PDF. The session is recorded, will be available for you afterward, exactly at the same link. You can right away bookmark what you are looking right now. It will be the same tomorrow. Okay. Just tomorrow you will be able to move faster to my dad jokes. Okay, so here is the Discord chat, question and answer. So first, how to create an account to Astra. Okay, so you click the button and you will go. You will be routed here, Astra login page, and there you sign up. You authenticate with your what you like, GitHub account, Google account. I will use my Google account. And I will connect to this solution. If you want to have a look at the documentation here, please go how to create an ASTRA account. Here you will see, you know, if you do like me, it's cool as well to put it small. Here you do have all the step-by-step, including some pictures, screenshot, and where to click each time. So if you get lost, the documentation is pretty helpful with a lot of illustration for you not to get stuck. So I log in, and now I want to create a database. Look, I already have two databases. I would like to create a new one. Okay, so here we go. And so the database name we want you to choose would be workshops. Okay, and the key space names Spring Pet Clinic. Okay, for the database name, to be honest, you can use whatever you like, but it's better to use those settings because later we have some scripts running and they expect those settings. I already have a database called workshops, so maybe I will call it workshops too. Okay, but because I already have one called workshop. So then ask a region. So the idea would be to pick a region which is the closest to you to reduce the latencies, but there is no difference. Okay, it's all free. They all are free. So, you know, pick the one you like. And when you're done, just click create the database. So the database will take a few minutes to start up. So here you can see that the status is pending. Okay, and why? Because this software as a service solution will create you a ring of 3 Cassandra nodes, not just an installation, to get the benefits of the distributed Cassandra thing, right? So it's pending, and I will let it pending. Okay, that's totally cool. And during the time it's pending, I can move to step number 5 and do it at the same time. So when we will do the hands-on, we need to use user and password to connect to your database, right? So no surprise. So to have your users and password, you need to create something called a token. So to create a token, here you do have the documentation, you can click, and I also put here a nice GIF with the walkthrough. So what you want to do here is going to organization settings, token management. Let's make it a little bit bigger. Then pick a role. It's a demo, but you know, pick database administrator. You won't get any trouble because this guy will have all the permission, quite a lot of permissions. But you know, if you use it later in production or anything, pick a role that does have the privilege only to do what you want you to do. So like only using the APIs or only using the data eventually. So here I put database administrator and I click generate token. So in a token, you will find 3 fields. Client ID is kind of your username, client secret, your password, and token is something that we can use, could use a little bit everywhere as API keys, and also could use as a password. So this one is quite important to save. So here I will download my token details somewhere where I can find it. So here it is. And I will keep it here because I really need it later. Okay. This token is not at the database level. It's at your organization, you know, the tenant where you live in ASTRA. So with the same token, you can connect to multiple databases. Okay. So what I can do is moving back to the home screen, and you know, I keep this guy open, just a tab there eventually when I need it. Okay. And here I'm going back to the home screen by clicking on the DataStax Astra logo. Okay, and here look, I'm coming back and now my database is active and I can use it as I like. You can use it as you like. And, you know, I could wait for you a bit. When you are set up, please give me a thumb up in the YouTube chat and we know we can move on and show you a bit more slide. Now the database is running. We need to create some tables in there. I see in the YouTube chat a question regarding the region. So when you create a database, let's say you do have 10 regions available to you for free, but ASTRA is available in, I don't know, multiple dozens of regions. So if really you want a region that's close to you, it's out of the free plan. So, and this is why you get the update button. But, you know, today, pick one of the 10 available to you. Okay. Tariq, Michel, Kenneth, Becca, Tristan, Chandrika, congratulations. Yeah, you keep it up. Good work. You rock, guys. So, guys and ladies, and look at that. It's half an hour, 30 minutes in, and we already have a database Cassandra running. So let's discuss what we want to put there. Okay, right. Shalia as well. Okay, the token step. Yeah, sure, for sure. So it's a step 5 in the instruction. And what you need to do is go to organization settings over here. You will be routed to a dedicated screen for organization settings. There you will pick token management because we want to create a token. Select the role database administrator. See, this is the one provided to you here in the README. Generate a token, and now I do have a new token. So here it is. Please download the token details. You really need this token specially, okay? If you want to copy in the clipboard right away, yeah, you can do it. You know, click it now. It will be useful in the next step, okay? And when you're done, you come back to the home page by clicking the ASTRA logo. Okay, I think I can keep moving with my slides, and in the meantime, you can you know, wait for the database to switch to active mode, or you know, create a token at your own pace, or even start navigating and clicking everywhere. If you, like me, the kind of people that like to touch things to learn how to use it. Okay, so let's talk about the tables, okay? If you have used relational database before, you know that what you tend to do is start with the data. You define your entities, and then you define some relationships, one to many, many to many, creating some integrity constraints. The idea is to have the same data available only once at a single place, and let the application build the proper queries, SQL queries, using some joins if they need to have joins. Yeah, this is how it works. So DBAs are king, and now you as an application developer, you have to figure it out how to build the proper SQL queries to make things work. Well, in Cassandra, you will see it's different. Now is important. In Cassandra, you will find some tables. Okay, it's NoSQL, but it's not like MongoDB, which is document-oriented. It's not like Redis, which is key value. It's like a little bit like DynamoDB, if you want, or HBase. It's a family of NoSQL database as a whole, where you will find tables. In these tables, you will find a primary key. You should be familiar with the primary key. This is the way to ensure the unicity of a record. But there is something else something maybe even more important in the Cassandra world. It's called the partition key. The partition key could be the whole primary key or just could be a part of the primary key. So because it's a part of the primary key, it's not enough to ensure unicity. So why would you use that? Well, here you do have a table with, let's say, 10 records. If I ask Cassandra to save that, this is what will happen. The records will be saved on a node based on the value in red. A single node is not in charge of a single value in red. Okay, for instance, here on the bottom left-hand corner, Sydney and Mumbai are in the same node. That means this node is both in charge of AU and IN. How does it work? Well, when you create a table, the primary key will get hashed. So you will have a function that will transform the value and get you an integer. And you can imagine that every node is in charge of a value of integer. Like that, the values are evenly distributed among the nodes. So that's pretty good, right? But, and this is a but, and you know, even if you have never seen Cassandra before, you can realize that. If now I do select star from my table, retrieve everything, it will work, but it will take so much time because I need to ask every single node to get a part of my response. So you want to avoid that. You want to execute a query where in the where clause, in the filter, you always provide the value in red. If you do that, all the data you will retrieve are on the same node. So there is no communication, and it will be as fast as possible. Long story short, with Cassandra, you will create tables based on your requests, based on your queries. You need to know what will be your requests and queries to build the proper data model and not the other way around. This is here what we put on the reverse order. You need to know what the application is doing to get the model and see which are the requests or queries needed. And at the end, you get your data model. It seems tricky. You know, it's really not really, just a different way of thinking. And let's apply this to our pet clinic. Let's see how it works. Because you know what? Pet clinic existed before we decided to move it to Cassandra. And it was a relational database model with some many-to-many and one-to-many and entities. And I just told you in Cassandra, well, you do not want to do joins. I mean, you cannot do joins. It will be slow. You need to find another ways. What is the other way? Well, I will show you an example, try to explain, but also on this YouTube channel, you can find a courses called DS220 or academy.datastax.com. Find a full courses explaining you step by step all the methodology to build a proper Cassandra data model. And how to do it? Well, there is a workflow with some simple rules. When you know this workflow, you can be quite, it can be quite basic. Just apply the rules and get something that works. Okay. So let's use this modelization, the methodology on pet clinic. Okay. We need to look at the application. So the first thing we do when you connect to the pet clinic is to list the owners. Okay. So that's the query we want to execute. So if I look at my relational data model, if I isolate what I need, it will be the owner. I only need the owner table to show you owners. Okay. No rocket science here. Look at the primary key. The primary key is an integer, and it's fairly common in the relational world because with integer you can find something called Oracle sequence or auto increment, stuff that will keep updating and creating a new ID for you. And the database can be sure that this ID is unique. But in Cassandra, each node is independent. You do not want to rely on other nodes to get a unique identifier. And if you would have used a sequence, you would have to stop the world, ask every node, oh, what is your last ID, to be able to get the new one. And doing maximum is tricky. You can run into race conditions. To avoid that, we are using called UUID, Unique Identifier ID. So it's not only to Cassandra, you find that in Java, of course, and all the languages. It's based on urandom. It's a low-level function on your laptop, and it will give you a random UUID. And I think there is more UUID than atoms in the universe or something like that. So it's a way to get a unique ID without introducing any dependencies between the nodes. Okay, so the table for owner will be pet clinic owner. This UUID is enough to ensure unicity, so it's the primary key, and it's good because it's ensure unicity. So one done. Okay, keep moving. Second would be get me all the pets for a user. Okay, if I click a username, I will get to this page. On this page, you see the owner information. So get the owner information by the owner ID. We can do it with the previous table we designed, okay, because we do have the ID. We can retrieve all the values for the owner with the ID. For this one, we are okay. What about this one? Find all the pets for owner. It's a one-to-many, one owner, multiple pets. If I show you the relational diagram, this is what it would like, right? One pet, one owner, multiple pets, one-to-many. Okay. Now is the time. Oh, wow. What do we do with Cassandra? Because you don't have joins. And here it is. You save together what you want to retrieve together. Instead of doing the joins when you read, you do the joins when you write. It's called denormalization. You may have encountered that before in business intelligence. You know, the database that we use at the end of the day to create some analytics and some dashboards. Those are using data model called Snowflake or Data Mart. They're using the same logic. Denormalization, having all the pets for owners in a single table. Okay, and if look at the name, it's called pet by owner. Give me all the pets for a single owner. So owner ID is the partition key. Why do we do that? We want to have all the pets for a single owner on the same node. Otherwise, you know, it will be slow. So owner ID will be our partition key. And then to ensure the unicity, we need a second row, here pet ID. And the primary key will have both the owner ID and the pet ID. The pet ID is called a clustering colon, and it will be used to sort, but cannot really sort a UUID, right? It will here be used only for unicity. Okay, so with this, you have a way to do some one-to-many. But now you may ask the question, hey, if I need the pets on multiple queries, what do we do? Well, you will duplicate the data. And that's something you're probably not familiar with. In Cassandra world, we consider that the storage is cheap and you want to store multiple times the same data if it's needed in multiple queries. That's the trade-off, to be super fast even with petabytes of data. Okay, that's the kind of new things from the NoSQL. We duplicate the data. Okay, keep moving. So owner, we have seen that we do have an owner table with a UUID. Vet, you can imagine the same. I have a vet table with the UUID. One-to-many, we do have here the owner. One-to-many is here. The owner of pet. You also have one-to-many between pet and visit. A pet can have multiple visits, and so you will have the same. If I show you the three first table, pet owner, pet by owner, visit by pet. Exactly the same logic, right? Now the big daddy. Many to many. How do you do many to many? Now you're stuck, right? Well, what you do with many to many, the general convention, let's say you do have a user table and group table. So a user can be part of multiple group, and of course a group will have multiple users, many to many. In that case, you will have two tables. The first table will be called user by group. When you query by group, you get the list of users. And the second will be group by user. You query by user and you get the list of group. And the same data is in both tables, even if the columns are exactly the same. And the data is exactly the same. It's just that in one table, the partition key is the user. In one table, the partition key is the group. And that's the job of the application each time to write in both tables. It seems a bit weird, but you know, it's not difficult. You know, you need to keep track. Each time I work with users, this is the three table I need to update. And you know, that's really not a big deal. But then you can have super fast queries. Here, it seems to be a many to many, but when you look closer, you realize that a vet could have multiple specialty, but here specialty is just used to get the name. You know, here you got the ID identifier, and here you get the name. So it's one-to-one. And there is ways to handle that faster. And this is what it looks like. So you retrieve the entity vet. Here you got kind of one-to-many with vet by specialty. But instead of using specialty by vet, what you can do at Cassandra level is have some attributes, some column, be list, set, or maps. And because specialty just a string, look at that. We decided not to create a new table, but just have the specialty as a set of text. So one-to-many can be done like that. One-to-many could also be done with this trick. Okay. All right. It was a lot of theory. I must confess. I know, but it's good to see the logic behind the transformation from relational to NoSQL. Now, guess what? You will create those tables in your database. Ready? Let's go for some hands-on. And now we will use the second tool that I told you in the beginning, the cloud-based development environment called Gitpod. I want to stay logged in. Okay, all right. So how to work with Gitpod? So we are step number 6. That's so French, right? Number 6. And so you will click 6 open in Gitpod. All right. So I recommend you to right-click or second right-click click just to open this guy in a new tab. Okay, just to keep that open. So when you first launch, GitHub is building the image. Yeah, it seems like this is what it's doing right now. So I will let this guy start. Okay. So as you can see, it's starting. You will see it's VS Code in the cloud. So if you have used VS Code before, you will not get lost. It's exactly the same. So it's opening a few stuff. There is a little bit of magic under the hood. We have set up the environment to open just what you see, the README, okay, some terminal at the bottom, and the Explorer here where you can see the files. So notice that here you do have 3 terminals. One terminal will be for the front end, one terminal will be for the back end, and in the bottom for the database, you know, the same layers as I presented to you before. And look at that. So here, maybe I could make it a little bit bigger. The terminal is asking you for your database token. When you will provide this token, this is the way to make this environment connect to the database and be aware of the database you created in ASTRA. So let me copy a token on another screen, and I will copy here, okay? So copies, Control-C, Control-V, okay. The first time you paste something in Gitpod, you can have this window asking, hey, do you allow some pasting? So please allow. And as you can see here, my token has been pasted. And now you can use enter. So can you use VS Code? Well, to have this running on your laptop, you need to have Java, Maven, and Node, because Gitpod expecting you to have those. So as long as you have them, it should work. But it's not out of the box. Okay, so I would rather advise you to use Gitpod for now, and later try local installation and ask us if you find any issue. We will tell you what you need. Okay. So I provided my token, and the script was able to connect to my database. It gave me back my database ID. I didn't told it which database it was, my region and my token. And if I go to ASTRA, look for the database called workshops, ID is 3ED blah blah blah, and if you go here, pet clinic is one of the key space. And so this is what I asked as parameter. Please connect to the database called workshops and the key space called Spring Pet Clinic. Here now you have a terminal with SQL-SH. SQL-SH, so SQL Cassandra query language, SH shell. So all the command that you enter here will be directly applied in ASTRA. Pretty cool, right? Pretty cool. Okay, so we have initialized SQL-SH. And what we can do here is describe key space. So here to copy paste using GitHub, you see you do have an icon here. So I click here and I paste. And here I do have the list of key space living in my database. I do have multiple key spaces because I've done multiple workshops. But the one I want to use today is called Spring Pet Clinic. So I will use Spring Pet Clinic, okay? And here it is. I could clear, and here now I'm using SQL-SH on Pet Clinic. Okay, I can quit, okay? I can quit with the semicolon and come back using SQL-SH. But I don't need to quit to get back immediately. So I will stay here. But I can quit and then go back using SQL-SH. Here I missed the semicolon, and maybe I should refresh. It should be there, right? Quit. I know it's not there. Okay, my bad. Here you miss a semicolon. Okay, so now if I go back to the second terminal code, the backend, you will see what I told you. It's better to use Gitpod. There is a lot set up for you. You do have Java. Okay, Java 11 is there. You do have Maven. Maven is there. You do have Node. Okay, even if it's here written 14, it has been updated, now it's 16. And you also have the Node package manager, NPM. And here we got the 8.1.0. So a lot of things are available for you in this Gitpod installation. We love to use it. Everything is there. And not only you do have it, but you also have Python, you have Docker, you have a lot of stuff ready to go in Gitpod. And you know, to open a Gitpod is always gitpod.io/hashtag and the URL of your GitHub repos. Yeah. Pretty cool. Give it a try. Anyway, for today, it's super useful. So here, then, we ask you to show the Remote Explorer. So this is the icon over here. As of now, not much to see, right? Everything is down. Soon we will start the backend. Soon we will start the front end, and you will have both green. But for now, they just are black. You know, I will probably come back here and start the web page from here instead of using some command line. It's so convenient. So, you know, even before starting, it was good to show you that it's there, and it's called Remote Explorer. Then, okay, 6E, validate your setup. I will copy, paste. So you know the script in the beginning where you were asked to provide the token? This script creating a file called .env. And in .env, you will find all the environment variables that you need to start to work with the application. The token, your client ID, your client secret, your database ID, your database region, and your key space. Oh, database region. It's true. I have not told you about the database region. In ASTRA, a database can have multiple regions. So here, for instance, my database has 2 regions. Each region is a different ring. Okay, so the pictures with a cluster and multiple rings I had before, this is the setup I do have right now on my database. Okay, so I will inject those variables in my environment each time. So this is why here you see set a source is to load all these variable as environment variables. Okay, so here, if I want to see if Java can connect to the database, I will copy that, which is load all the environment variables in the environment, load all these settings in environment variables and run Java. And I will show you a bit later how Java load those values, but let's see if it's working, okay? So the guy is trying to connect, doing some logs. It's starting a Spring Boot application. We'll explain you soon what it is. Was able to find my database with the ID, and yeah, was able to connect. So my key space is Pen Clinic. Thank you very much. I was able to list the content of the table, okay, and doing this. So cool. Okay. All right. So let's go back here. We need those tables. You need those tables, okay? Those tables may not be created. You need them. How to do so? Here you do have the script called a DDL, so domain definition language, to create all the table I've shown you before, okay? So let me copy that block and paste. Here you see some drop. So if the database existed before, it will be deleted and recreated. Some can lead to timeout. It could happen, you know, in between Gitpod and ASTRA sometimes, but most of the times everything is okay. And when the script is okay, like me right now, you can execute 7D, describe the keys, the tables, and look at that, my 6th table have been created. Cool. How to insert some data? Use insert into. As you can see, the Cassandra query language is pretty close to SQL. It's not exactly the same. The types are not exactly the same. Here we were able to insert a list up front, but for somebody who is familiar with relational and SQL, it's not too difficult to get into Cassandra query language, right? It's quite the same, right? Okay, and oh, we created 2 stuff, and if I want to see what we created, I can select from. It worked. Remember, it's not the greatest to do select start from a table without the where clause, because you need to use all the node to get the request. But my database is empty, right? So it was so fast, even doing what we call a full scan cluster. Okay, it has been an hour now, and we do have the schema created. Believe me, it was a big chunk of the app. In Cassandra, as soon as you do have the data model right, the rest is just music. Okay, just deliver. Because if you created your data model, that means you already know all the queries you need to have. And so your design is mostly done. Now it's just boilerplate and code building, which is still my favorite part. All right, okay. Now we will start explaining why we are both Java folks explaining new stuff today. Let's go back a bit to slides to discuss now the backend. Okay, we are done with the database. Maybe I could have some thumb up in the chat if you are still with me, and if you were able to create your tables, and if everything was successful. Yeah, tell me. We are good on time. Hey. I had, like the sweat. Oops, no response. Okay, Kenneth. Yeah. You will have time to catch up. And if you got some issues with the script at the beginning, if that happened for some reason, what's happening is there is a script called install SQLSH that you could re-execute if something goes wrong. Okay. But beside this, you should have one terminal with the database, one terminal ready to execute backend, one terminal ready to execute frontend. And with that, moving back to the slide. Once you created the database, we created a token. And as soon as we had the token, we open Gitpod and we execute the instruction step 6 and 7 to create the tables. Everything is in GitHub, and you can really do step by step. Copy pasting all the commands. Okay, and yeah, I think I will let Stefano get this question, and I keep moving. So let's pretend your database is now created with the tables and a little bit of data. You want to connect to the database. The way to connect to the database is always the same. You need a driver. If you are using a relational database, you will use something called JDBC in Java or ODBC drivers. Okay. And here there is no difference. you will use something called drivers, Cassandra driver. Okay. DataStax is famous to have created those Cassandra drivers that allow to do connectivity, queries, and parsing the result for everything we do with Cassandra. Okay. To use the drivers to connect to ASTRA DB now, instead of providing the IP of the nodes, because it is a Cassandra running in the cloud and only available through HTTP, you need some certificates, keys and certificates to open a two-way TLS connection. And to get all these certificates, Trust Store, Cert Store, you will download the zip from the ASTRA user interface. But guess what? With the settings we have for you today in Gitpod, you don't have to do it. But you to be aware, when you are using ASTRA, go to ASTRA, go to the workshops, and yes, the script is explicitly picking workshops and creating it if not available. So you can rerun the script and it will work. There, you do have a page called Connect. If you want to use Java, you will be invited to download the Secure Connect bundle as a zip. Fortunately, for today, the Java code will do it for us. So long story short, ASTRA is quite secure. You will have a two-way TLS connection open between you and ASTRA, but it's super and strongly secure with a certificate. Okay, now if I put back my three layers, front-end, back-end, and data. And in the back-end, I put both the APIs, which is the endpoint, and the drivers, which is how to connect. The first things you need to know is to connect to Cassandra, you need an object called SQL session. Okay, so SQL session is a singleton, so should be a single SQL session in your application, and it's stateful. This guy will maintain the connection open to the database. So make sure to close SQL session when you close the application. But as soon as the application is connected, you do have access to SQL session. Okay. Now with SQL session, you will execute queries against the database, also called statements. Each time you execute a statement, Cassandra needs to validate the syntax. Is the grammar is okay? Does the table exist? Do the colon exist? And it could take some time, all this preparation. At startup of your application, you can prepare your statement. So you can make this validation once for good. And each time you will invoke your queries, you will not use simple statement. You will always use prepare statement. All the validation is done and you gain 20% of performance. Okay. So now let's pretend my request is prepare. I do a prepare statement. What do I do? In the user interface, I use the parameter that has been provided by the front end, took my prepare statement, took my parameters, mix them together. This is called bind operation. You get a bound statement. You send the bound statement to the database and you get your result. Woohoo! Result set, you get your result. You're happy, right? Well, you're happy. What we could find annoying is all those operations are blocking. During all the binding and executing and getting the result, the thread was blocked just for that. And it's a backend, but it's a REST API. It's an HTTP server with some limited thread allocated for you. So it will be a constraint if you want to do multiple thousands of operations per second. which is annoying because Cassandra can do thousands and thousands of operations per second. If your API is a blocker because you do have the thread lock, no good, right? So can we do better? Let's see. So synchronous is good. This is what we all use on day-to-day. It's good enough for 80% of the use case, okay? It's simple to use, easy to maintain, okay? So don't try to go something else if synchronous is enough for all your use cases, right? Keep it simple, stupid. Still, it's blocking, and because it's blocking, the scalability is not the greatest. So you can think, and you will think about asynchronous, and you should think about asynchronous. Now, so of course, the drivers support asynchronous queries. You will send the parameter, bind, send the bound statement. Bind is pretty quick, okay? Bind is ready, take parameter 1, take parameter 2, mix together, and request something to Cassandra. So maybe the diagram should be, what is long is ready for Cassandra to execute the query in that process. In asynchronous, instead of giving back the result, it will immediately respond a completion stage, a future. Okay, so you in Java, you do have a future, and so you will work with the callback. When the operation will be ready, you will get onComplete, and you will implement the onComplete method, and you will get this time asynchronous result set, and from that you will get the result. Now it's not blocking anymore. What you need to realize is these notification, this callback will be done for each page. In Cassandra, all the requests are paged. You don't want to do select star from Cassandra and get all the results in one go, okay? Best case scenario, you blow up your application because you get billions of records. Worst case scenario, the Cassandra nodes has less memory than you, and this is Cassandra nodes that blow up out of memory because Cassandra is also a JVM. So no, all the Cassandra queries are paged. 5,000 is the threshold by default, and you get a notification by paged. So now with asynchronous, you are happy because the calls are not blocking anymore, and you can get some scalability and make the threads work, split the thread for getting the HTTP request from the thread that will execute queries on Cassandra. So yeah, two thread pools, and you can execute better. Still, it's not a silver bullet. Now, if you have multiple nested calls, one inside the others, if the one that's the most nested call, if something goes wrong, what do we do with the previous call? It's, you have to think about some exception management in asynchronous. This is, believe me, it's super tricky to do. And this is not me inventing this term. It's called the callback hell. And, for something, I trust you. What about the maintainability? You will start to put some, blocking point, toggle point on your IDE, but nothing is blocked because it's asynchronous. So you're still stuck. Yeah, it's not easy to maintain. So can we do better? Yes, we can. And it is why this workshop is called Reactive in the first place. So, but before going into Reactive, and not too soon, I will show you a little bit of this connectivity. What about this SQL session? What about this execute statement? Okay. All right. So go back here, go to my backend, clear, make it maybe bigger for you to see what I'm doing, showing the code. Okay. So the first thing I can show you is how the parameters have moved from the environment variables up to the Cassandra world. So we are using the Spring framework. I told you a little bit about it in the beginning. We will come back to it very soon. So this Spring framework have multiple components. One component is called Spring Boot, And Spring Boot expects all the variables to be in a single file called application.yaml. Okay, so Spring will be there, and you define some keys dedicated. Okay, so here this is the port, HTTP port you want to listen, and this is some Spring Data Cassandra settings. Okay. We use a dedicated Spring component that works with Astra called a Spring Boot Starter. So something that will tell you tell Spring how to connect to Astra. And you only need 3 parameters: the token, the database ID, and the region. Oh, surprise! This is exactly the environment variables that we do have. And this is why the unit test was able to execute, because we can load those parameters and make that available in Java. Okay. So now let's see. Oops. I want to paste here. I can also, okay. Okay, that's my DAO. Maybe I want to show the test before. Test 01 that we did in the first place, okay? What we did, we asked the application, give me a SQL session, the one that has been created by the Astra component. Give me the key space, and execute select values from reference list where list is pet specialty. And we got the result. Okay, so our unit test will inject, reuse the singleton SQL session everywhere to execute queries, statements against Cassandra. Okay, so it was test 01 connectivity, and nothing special here. Was just, hey, give me the key space and execute a first query just to see if I can really connect to your database. Okay. Second will be creating your own service on top of this connection. So here, look at that. I do have again my SQL session, inject from the Spring context. Okay. And then I will create prepare statement. Remember, this is what I've shown you as environment, as a sequence diagram. So here, at initialization, I will prepare statement, insert into, select into. That way, it's initialized once, and when I need to use it, I just have to execute. So how to execute? Here it is. Session, SQL session dot execute. Okay. This guy doing execute reactive, and in a minute, Mary will tell you what is reactive, but everything is reactive in the app. So it was the only way for me to show you SQL session dot execute. Okay, so first prepare statement at load, and then execute when you need it. Maybe last point, why this code is executed at initialization of the application. It's a Spring trick. You ask your bin to implement initialize bin, and yeah, notification are off. Initialize bin, and you have to implement after set properties, and this code is executed as initialization. Okay, and now if I want to execute this test, I can copy that and test. So to execute some test in Gitpod, we are using Maven test. I found it easier than right-click, try to test it as GUnit as you would do in the IDE on local environment. The reason is you will have more settings to do, and here no big settings. You can do Maven testing. So test run 1, error 0, and I was able to retrieve the list of the veterinary type: dentist, radiology, surgery. Okay, right, Cool. As you can see here, I'm using directly the SQL session. But maybe this is not what you want to do. You want to work with objects, and you want to let something else work with, save the data in your objects. So here, let me open Vet Reactive Clinic here. Inside the core Java driver, there is a way, it's called the mapper. There is a way to define an object as an entity, define a DAO, which is an interface with no implementation, no SQL. We don't tell the guy really how to execute, which request to execute, but it will be able to find out what it is. Okay, and you don't need a third-party tools to do it. You just need the core drivers. Okay, so you could execute test 3 if you wish, but that's really a way to use still only the drivers to do mapping from the object to the database. Okay, and now I think we can show you a bit slide and talk more about Spring, because mapping from object to Cassandra is also what Spring is doing for you using something called Spring Data. Okay, so go back to slide, and now I leave the floor to Mary.
Thank you, Cedric. Thank you. That's a lot of materials, in the just the data itself. I think, so now we get into the reactive part, and as such, I've worked with some reactive systems, so we'll be very happy to talk about it. So if you're new to reactive, there's actually a difference too, just to point out, there's difference of reactive programming and versus reactive systems. So the programming part is more with the program itself, and then utilizing kind of a functional style in Java, right? The functional style of programming to implement the reactive. But when we get to like reactive systems, we're dealing with systems as a whole. And essentially too, this reactive manifesto is what defines what a system is, if it is reactive. There are 4 tenets, as you can see in here. This is actually an enhanced diagram, because otherwise too is normally you see the 4 tenets: responsive, elastic, resilient, and then message driven. But this is actually a great diagram to further kind of explain it a little, in which, it kind of divides up into the value, kind of top part, responsive, and then the form, and then the means, right? So value is what we're expecting. Your systems have become really, really responsive. It helps with the real-time kind of processing of all your data that it enables, right, in a very efficient manner. And the form it takes is really elasticity and also resiliency. So elastic, it means that systems can very elastic. It's very scalable. So if there are more requests coming in, your system will automatically, or processors will get in number of processes to handle all of your requests will increase. But if it is, if you don't need anything, it will kind of scale back down. So it kind of explains that elasticity and essentially increase the throughput of your system. And then there's also resiliency, which means if your system fails anytime, then there will be components, especially in a cloud native environment, that your node goes down, something, right, that is running, and you have another one that comes step right in to take over. So then your throughput should not suffer. And then that's the idea of resiliency, the recovery aspect. So these are like forms. And then the means of it, how can you achieve it, is really like through message-driven kind of approach. As well as there's also like event-driven too, which is slightly different. But the message-driven part is indicating your request and response. There's a sender and receiver. They kind of know each other. The address is known too. But otherwise, event-driven is more a pops-up kind of approach in which messages get emitted, and you don't really worry about who it goes to. You go through a broker. A broker will take care of things, and then you label your messages as topics, right? So that's kind of in a high level. But as you can see too, the very top to the value, the responsive, is essentially the making it very maintainable and also very extensible too. So that's what this Reactive Manifesto in a nutshell. But if you want to go into more details, there's plenty of information, and Lightband is the company that actually drives this initiative too. That there are a couple other companies, and now there's Reactive Foundation that's kind of backing the Reactive Manifesto. So it's a bit in a nutshell. So we can go to the next slide. Yeah, in the interest of time too, I won't go talking. I'm not doing a full-blown presentation. I mean, I've done that, but it's not here. So
but we
okay, so this will
be up running. Yeah, indeed. Yeah.
Yeah, that's right. So, but yeah, we can discuss further on the Discord channel if you're interested. Okay, so here it is, right? So there's also in reactive systems in the reactive world, there's a specification as such is dictated, or kind of, I shouldn't say dictated, governed by the Reactive Foundation, which is part of the Linux Foundation now. And so they come up, there's a one specification that's actually called Reactive Streams, Reactive Stream API. As such, too, if you can kind of take a look into the API, there are no implementations, then just interfaces. Essentially, the publisher, subscribe, and then the subscription, and also processor. These are the four kind of interface, right? And then it's up to the vendors to implement this. That is something, too, I would suggest that is not for the application developers to implement it, because it gets very complicated, even though you think, okay, there are only four, kind of methods specified in the interface. But go ahead and do it. But guess what? When it deals with concurrent programming, it's no joke. Yeah. So rely on your providers, right? Service providers, such as over here. We see that there's RX Java, Spring, right? That is what we're working on, Spring Reactor, the web Flux. It makes use of Flux and Mono and Flux kind of mono and what is it? I kind of get confused because Vertex, right? Vertex also is another library too. It's an Eclipse Foundation. So these are all open source projects. And then there's Akka, which is from Lightband, and it makes use of actor model. Actor model is actually a concept that's borrowed from Erlang, the language, right? Erlang, back in when telecommunications needed the asynchronous style of communication. So Akka borrowed the actor kind of model of the sender and receiver, the request and response. So very efficient too. So yeah, these are like the kind of de facto standard if you want to go for any kind of reactive libraries. I would think, yeah, these are good ones to go after. And of course, today we are going to talk more about the Spring side, how it supports it. But as you can see, right, there's publisher, subscriber, and makes use of the event-driven model that as you can see, so quickly kind of go over, right? Reactive streams, and then it makes use of subscribe. So if anytime, you want to subscribe to messages from the publisher, you do a subscribe. And then on subscribe, basically, then data comes, from the publisher, it emits some data, then the broker essentially will be sending the data over to the subscriber. And then, basically there's subscription requests. And then there's also the on next and on complete. All of these things are all within the this definition of the interface too. So as such, right? And this is the reactive stream. So in a nutshell. So
no, it's great. It's great. So okay. How the driver use this magic?
That's right. Yeah. So exactly. So now this is your example of this kind of state kind of transition, right? Kind of thing. So UI, you have your parameters sent to the API, and then from now then putting them in within the database kind of context, Cassandra, ASTRA, right? And so now the API, there are prepare statements and parameters. And basically then, yeah, the driver then will bind the parameters. And then essentially this is what it is. And then it comes back with the reactive, the bound statement will come back with the reactive result set, and then sending it over to the Flux back to the UI. And then basically in this case, then you will execute the query, and then goes to the Cassandra now at this point, and then it fetches all the rows and then comes back, and then again, back to the driver. Then there will be reactive row kind of result set, and then comes back to the UI. And essentially too, like on next, and same thing, then the subscriber will kind of on next is essentially the next available row that it process. So, and then when it's done, then Cassandra, there's on complete, then it will kind of go back to the UI and basically indicate the completing of this query. So yeah, so that's like kind of a quick kind of explaining of this reactive kind of processing. And again, it's very asynchronous in nature as well, this call. Yeah, I mean, what we're showing, it seems like it's kind of one step like that, but it can be happening at any time, kind of depending on the thread, right? Behavior of the thread and all of these complexity with concurrency through the threads. So yeah. Okay.
Yeah, it's you got this notification for every single rows and not anymore for just a notification for each page. And it could be a lot of notification, right? So if you get one every single row, maybe you cannot keep up. So look at that. The driver does have a back pressure mechanism just to say, hey, please stop. I cannot keep up.
That's correct. Yeah, I totally actually forgot about the back pressure part when I talked about reactive streams, and that's the primary thing, right? Besides it being non-blocking support is basically back pressure. If you get too many, requests coming in, then you need to have a way of kind of balancing, so then you don't overload your broker, your processor to be processing these messages. So that's like back pressure. So as you can see, yes, it's the driver in there that actually the client going to Cassandra, and the driver will be there. The reactive driver is managing through the use of the implementing the reactive streams to kind of control the flow. Essentially, it's a flow control mechanism that's kind of built into this back pressure during a read. But then over at the right side, then there's no back pressure support too, based on this. Now, just a note too, to also notice, right, even in this case too, in reactive too, like if you are sending a request, right, to the to Cassandra and you want to get the data. So the request, at the time you issue your request, and it will essentially capture the state of that data set at that point in time and return you that set of data. Now, during the time in which you send your request and then it comes back, there could be actually more data happening too. So what to do, right? So in other words, you're not having this, you don't want to rely all the time on eventual consistency principle, right? Meaning that, well, you're getting things that aren't quite exactly accurate. But then the thing is too, the solution that we have in here is basically using a new concept, well, not new concept, but a new feature that we support. This concept is called Change Data Capture, CDC, right? So not like disease control here, but it's CDC for Change Data Capture. So that one is actually, that feature is available in ASTRA. Now we just announced it, and then it's basically capturing change as such, right? State changes in your data is being captured and also being reported right back. So as you can see, it provides this real-time data very well. So yeah, so I think if you can go to the next slide for me, please.
Of course.
Yeah.
Here we go.
Yeah. So, okay, so here too, we still have to have a proper kind of flow diagram, but just wanted to kind of give you a heads up. There's actually, we have ASTRA streaming that we have already announced the availability of CDC. And again, it captures data on the fly, right? But underneath the hood, I just wanted to point out to you is the pattern. It's called capture data change, right? It's within Cassandra and ASTRA streaming, we implement that. But in order to do that, we actually also leverage on the Apache Pulsar capability too. And so here at DataStax too, we have the ASTRA streaming, Luna streaming that's essentially making use of the Pulsar, the PubSub capability to help with capturing these change of data. So basically, it's coming soon to a data source near you, so please stay tuned. We will have more materials that will be talking about it in the CDC ASTRA streaming that will be launching, I think it's next week as something, yeah, coming, yes, I cannot remember the dates, but in 2 weeks, right, in the 21st.
Yeah, and you can go to the ASTRA user interface and already set up some beginning of a streaming. So I think it's even GA this
that's
week.
right, exactly. So yeah, you can go to the same, exactly, the ASTRA streaming. And pardon me, as I just joined DataStax, so some things I'm still like, kind of like looking around, feeling my way. But anyway, yes, the ASTRA streaming actually over there. If you want to play around with this feature, you can actually go to create streaming. And then you can follow that too. Yeah. We will be having more materials to share with you too. So yeah, so essentially, use this feature.
And exactly. I think we do have a workshop exactly on that, April 20th.
Yeah, that's right. Yes, yeah, in 2 weeks.
So it's in 3 weeks from now, it will be dedicated workshop on
That's right.
CDC.
Yeah.
So pretty.
Thank you.
All
Okay.
right. So moving from reactive to Spring Data. So is Spring Data reactive? What Spring Data can bring?
That's right. So yes, so for Spring Data, right, as such, a Spring framework is also very extensive, and as you can see, there are different kind of sub-components, so to speak, right? The different features that it has. So as you can see, there's a Spring Reactive, so it's kind of through the project reactor, and also the Spring Web Flux, which is more for the web kind of side of reactive support too, that forms this reactive backbone for the Spring kind of whole framework itself. But as such, Spring is very opinionated, very efficient, right? And it's being widely used by the Java community because it is opinionated, but it's also very efficient. You actually, it takes away a lot of the complexity of what Java used to be, right? In the Java early days of J2EE. So it kind of make it a lot simpler to use. And now actually the Java itself too also has caught up after Spring comes out too, and which is Jakarta EE, just to mention about it too. So yeah, so as you can see, right, all of these Spring microservices, among other things, right, microservices, reactive, cloud, web apps, serverless, event-driven, Spring Batch, for example, and these are like kind of major features that comes out of this Spring framework. And if you want to use reactive, yeah, use the reactor. So yeah. Yeah, and then there are also then Spring projects too that are many more too with that, right? And these are kind of more actual projects that you can actually use to develop your application. So Spring Boot, Spring Data, and that's what we're kind of looking into this the consistent approach to data access, relational, non-relational, map, reduce, and beyond. So that's the Spring Data that's working with our Cassandra. I guess Cedric, you can kind of expand on this part too, right, with Spring Data.
Yeah, I think it's a galaxy of framework. You can spend your whole life on Spring. But for today, we will use Spring Boot, which is the runtime, and Spring Data, which is the data layer. But there are many, many
That's
more.
right, exactly. Yeah, see, over here, Spring Security too is also a big thing. And if you want to do batch processing, then leverage on the Spring Batch. And then there's also Spring Cloud and Spring REST as well. So these are kind of the more.
I may be wrong, but I think next week we will have the Spring Security talks, because we need to authenticate in the e-commerce application.
Oh, cool. Yeah, great. Yeah, there's tons of things happening. Yes. Yes.
Oh, yeah. Every week's a new workshop. And so with Spring, you can have layers like a hamburger.
Yeah, that's
right?
correct. I love this slide actually because it's getting to be lunchtime and for me in Chicago. So yeah, so as you can see, I mean, Spring Boot itself is very much a layered, takes a layered approach of separation of concern, right? You have databases that supports SQL database, relational and NoSQL. And then there's persistence layer. That's actually the Spring, the repository layer to help with the persisting data, like kind of back and forth between the business and to the database, and then fetching data to the business layer. And then if you go up business layer, that's where you write all of the services that actually interacts with your persistence layer. And then of course, then very top will be presentation layer that makes use of the MVC controller kind of a mechanism to do presentation too. So yeah, so this is kind of like a typical Spring Boot application. And of course, if you want to initialize one, they have Spring Boot initializer that you can quickly set up an app to. So.
Exactly. And it's, super. And we do have that in the app. If you navigate the code, you see, so the NoSQL database is obviously Cassandra, then the drivers, repository. You can find a couple of repositories, services, and controllers. It's written exactly like that in the app today.
Yeah. Okay. And now.
Multiple tracks in Spring,
So reactive stack, right? We can talk about, let me be a little bit faster now. So Spring Boot 2, so this has the reactor, as I mentioned, the reactive stack. As you can see, if you use a reactive stack, how does it kind of compare with the old traditional servlet stack? So as you can see, it's actually it's making use of Netty and servlet 3.1 plus kind of containers. And it has the reactive streams adapters that it supports reactive streams. And then there's the Spring security reactive that we were talking about. It actually adds in the reactive flavor to it. And then Spring Web Flux is basically Spring MVC kind of on steroids. It's basically for reactive, right? Kind of reactive steroids. Anyway, then there's also then Spring Data reactive repositories that we were talking about. Cassandra, right? Namely, this, of course, is the best of the bunch. And over here, then all of these other solutions that you can use to, actually, R2DBC also has the reactive driver. Well, actually, I worked a little bit with that earlier. So yeah, and then of course, then there's Spring. Otherwise, you use the traditional Spring Data repositories with JDBC, JPA, and NoSQL. But yeah, but as you can see, reactive side has all of the reactive toolings for you to be ready to get onto the reactive way of doing things. So yeah.
Yeah, Cassandra is the most important, of course.
Yes, of course. Yeah. Wonderful. And this is the Spring Reactive Stack. And as you recall too, I think Cedric already brought up a slide with that. But over here with a similar one, right? That this one has the reactive flavor to it. So as you can see over there, the right side, the databases, we still have Cassandra, the data layer. And then in the middle tier, the application tier with the backend, you see there's data stacks. We have drivers that still make use of the CQL session. And it interacts then with the Spring Data Cassandra in the repository. And then it goes up to the Spring Web Flux. Then it's essentially the Spring Boot application that has the reactive side of things and interacting with Cassandra through the CQL session. So, and then of course, then it's all like through inversion of control, the injecting of resources as they need to, and yeah, dependency injection kind of way of doing things. So yeah. Yes, and then they were serving data then to the front end, the presentation, the front end of Angular, Node, or anything, in fact. So, yeah.
Yeah, and I think this is what I will show you very soon in the code, right? I think maybe the last piece is you set up a Spring Boot app using some starters. Something that will set up all the component needed. There is one for ASTRA, and this guy will help you connect to all the magic of ASTRA. It's not only Cassandra. There you have others product like Pulsar and others way to interact with the data using some APIs. And we cover those API on multiple workshops before. But today let's stick into SQL. But be aware. These applications that you have today could be reused to also interact with the others API if you want to. Yeah. All right. Okay, we'll move quickly to this one, I think, for sake of code. And, I think now we could probably just go in the code. I will go in the code and do it all, right? The Spring Data, the API, and the app full-fledged. Yeah, just to be able to play a game on time.
Yeah. Okay.
Okay, so okay, so let's see what we do have here. Working with Spring Data. So remember these code I showed you just before that you could map an object to a table using the drivers. Spring Data does exactly the same. It's just using a different set of annotation, and it's working with normal stack, if you wish, synchronous stack, and reactive stack. And if you go in the code over here, you will see a package called Spring Data. Come on, Gitpod, open me, please, my Spring Data package. If Gitpod is happy with me, come on, Gitpod. Okay. I could go to plan B. Okay, finally. So here you do have an entity. So remember, we do have a table called vet. Okay, and here I'm using some ID, first name, last name, specialty like you want to do in Java object programming. And I put some annotation to do the mapping from class to table, right? And then I also create an interface. So nothing there. It's empty. And I just say it's a Cassandra reactive repository. Nothing more. And if you look at the test, so here I inject reactive Cassandra repository. And look at that. I'm able to invoke some method. Insert, saved, update, delete are available part of the interface. Those are being generated by bytecode manipulation in the runtime, and I don't have to use to insert the SQL statement myself. It's done by Spring itself. So pretty cool, right? Don't have to write the code by yourself. By the way, it's a reactive code. So if I just invoke that and do nothing else, nothing will happen. Because in the reactive app, everything is lazy. If you do not introduce something what we call a terminal endpoint, terminal call like block, nothing will, or subscribe, nothing will happen. So to cope with that and be able to do unit tests in the reactive world, Spring provides a step verifier, and you just execute what you want. So you will retrieve either a list, so multi-valued, or single-valued. When something is retrieved and is single value, this is what we call a mono. And those terms are a part of the RxJava, more or less. I don't think they are everywhere, mono and flux. So mono is for one object. And if you get a list, you will get a flux. Okay, so that's that's the two objects you need to be aware in the reactive stack, mono and flux. So here I will retrieve a mono, so expect 1, expect complete, verify, just verify that the mono is complete. And I insert something, and then I can find it by ID, get the mono again, and expect that is complete. And with that, you can execute test number 4 using the same trick. Load all environment variable, execute test number 4, which is this guy, and I should save an item, retrieve an item. That is the DAO layer. Okay, so let's say we have 6 tables and 6 DAO, exactly the same way as you have seen on screen. If you remember the slide, there is a layer on top of the DAO that's called the service layer. And the service is useful when you need to chain or compose multiple calls to the DAO. And in this application, it could happen. On the screen, remember when you invoke everything related to owner, you will list all the pets. And then for every single pet, you will list the visit as well. This pattern is called n+1 select. I will list every pet, and for every single pet, I will again do another invoke. Well, when you are synchronous, those are super slow, right? Because you need to wait for everything to happen. With reactive, that's pretty convenient because you can work with the flux and doing some mapping, flat mapping, which is another method to do so. So if I go to visit and now I use the reactive services, here you can, so here I retrieve stuff from the DAO and just map. So maybe the owner will be better to show you that. But if I show you the owner full screen, here you can see. So I retrieve all the owner.find all. This is Spring data give me find all, which could be pretty dangerous, right? Because if you do have a lot of stuff in DAO, you will get a lot of data. But then I able to flat map, and for each item retrieve, I can populate this object to add more stuff. And all these flat maps are done side by side, asynchronously, in parallel, to have my service super, super fast. I don't need to wait for first entities to have been mapped to be able to invoke the second. It will all work asynchronously, and you will speed up this n+1 select pattern. Okay, so DAO layer, service layer. So in a service layer, you will probably inject multiple DAO because you need to invoke multiple tables, right? At the service level in a Spring application, you expect to find more or less exactly the service that will be exposed through your APIs. But still, in Spring, you like to split things, right? You like to, leverage as much as you want on inversion of control, just not rely on the implementation, but, keep injecting and splitting layer after layer. Also, something to notice, the package organization, if you work with owners, you like to have all the controller, service, and DAO layers inside the same package. In the old Spring, we used to have a package for domains, a package for DAO, a package for services. It's not as it has been designed now. It's recommended to put all the same function in the same package. So here, I do have reactive services. And now if I go to the controller on top of the services, this is where we start using Spring Web Flux. We do have the service here, inject in the controller. And so we will expose APIs with directly reactive object in the signatures. Here I retrieve a flux of owner. So the API will act as a reactive API, give me a flux and item one after the other, getting the notification for every single owner, not having to wait for the full list to have been processed before getting the first items. So I can start processing even before everything has been retrieved from the database. And that's kind of the magic of the reactive. So here, this is the service call. Here, this is the signature, nothing special. And here, this is how to expose a method as a REST API. This is nothing different from Spring Web. Spring does have its own set of API annotation. It's not G2E. So G2E would have used the specification called JAX-RS 2.0. Here it's a Spring dedicated signature, but here request mapping, so that the path in JAX-RS, just to say, hey, if somebody used that URL, this is the controller you need to access. Then get mapping. So if you invoke the get method and you provide the last name as parameter, provide the last name as a parameter for the service. So expose as API with the documentation here. And I will show you what the documentation look like. Get some reactive object in the signature. Use reactive services, invoke reactive DAO. And that's reactive from top to bottom, and nobody wait. And by the way, if you from top, if you introduce some blocking code, Spring will not even start. It will say, there is a blocking call somewhere. I don't want to start. And sometimes it's just, it upset me. Yeah, you have a blocking call hiding in a library, and you cannot start your app at all because it's not fully reactive. So it could be super useful, but also sometimes if you're not be careful enough, you can get stuck. Okay, so enough talking. You have seen the multiple layers, so I can show you. So this is what I call you with Web Flux and the services. So now maybe what you want to see. So I've showed the controller. What you want to see is the application moving. So I will again, so set all the environment variables and run the app with Spring Boot run. Okay, so it's starting, and this is where if I go to my Explorer, I should see the backend going to live 9966. It will, I think, open a new tab directly for me. If not, I will create it one. So is it coming? Maybe, maybe not. If not, I will just do it myself. So to open a new page, remember, click here. So as you can see, I'm invoking 9966 and I'm going to Swagger UI. Okay, so it's coming. Remember when I told you about documentation in the controller, this guy, API responses, because in my code, I use this set of annotation when the app starts using a third-party library called Swagger or OpenAPI, or I mean, go to the pom.xml. I think it's called SpringFox. Yeah, SpringFox boot starter with the annotation, and boom. Why this is cool? Well, you don't need a user interface. You can say, hey, I want to get the list of the pet. So this is all the REST resources exposed by the API. I want to list the pet type. I go here, I try it out, I execute, and look at that. Hey, I can use my API, and I can give my API to the front end, and they can start learn how to use it while they are building the web page. Okay, but hey, this is not what you want to see. You want to see the full-fledged app, right? So I will stay this backend running, okay? And I will go to the Pet Clinic Angular. Okay, so here Pet Clinic Angular. So this time it's a Node application. I won't go too much in the detail of Node. The purpose of the workshop are really focusing on the backend. But in the Spring Pet Clinic community organization on GitHub, you find the Angular application and you find the React application. So what you want to do here is go to the proper folder and npm run start. Because I think npm run build has already been done for us. So it will build. And eventually, look at that. Because I have npm run start, that 4200 is now open. I will open a new tab. And then, you know how JavaScript works, right? You download half of internet and it's starting. So what my browser is doing now, it's downloading, I don't know, Angular or half of the... Okay, it will take a few seconds to load, but fortunately, it will end up by showing my app command, and this app invoke the API here that invoke the database that we created all together, and you will have the 3 layers working. Yeah, it's downloading half of the internet, you know. The first half when you build, node install, and the second half when you run the app. Okay, so so many JavaScript has been downloaded, it should work now. So here, if I go to owners, oh, that's empty. Okay, so here I got my pet type. So what if I like to add a giraffe? Can I add a giraffe? Save. Yeah, okay, I do have a giraffe. So now if I go to list the pet type and I want to try it out, which are the pet type, and execute. Where is my giraffe? Here it is. And if I want to go to ASTRA and log into ASTRA, come on. And I will be done because it's my database. Okay, it's loading. Oh, I can also use the SQL console that we have still open here. So pet type, if I execute pet type, I do here have my giraffe. Oh, and seems like some insert at the user interface level just get me a space. Okay, so we have a bug to fix. But yeah, you got the idea. So you do have the front page. So with the owner, add owner, maybe. Yeah, I don't want to see everything, blah, blah, blah. Okay, my address, my city, my phone. Okay, okay, add owner. That's me. Add a new pet. So let's pretend I have a dog called Shadow, born last year. Yeah, you got the idea, but hey, I can play a little bit. It has been 2 hours. So here, and it's a dog. Yeah. And I do have another dog, Sally, born the same day. Okay. Okay, it's also a dog. And okay, now if I want to add a visit to Shadow, let's say next week, to get his vaccine, this is how I do it. And I can go back to my database and start looking for owners. But here you have the UI invoking the API, invoking the okay, pet clinic. What is the name? Owner, no S. Blah 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 blah. CTTT does not exist. Yeah. Okay, and here I am. And yeah, I can also select, of course, pet by owner to get my Sally and Shadow. Here they are, Shadow and Sally. And yeah, you have the full CRUD application from bottom to top, all working, everything for free, and you have the code for each layer. So you could still ask questions in Discord if something is not clear. But guess what? It's time for the game, because we are at the top of the 2 hours. So hopefully you learned something and you were able to go up to the end and have the stuff working. If not, do it at your own pace and keep asking on Discord. Would be so happy to help you all. But now, okay, thank you, Francisco. So yeah, now I will fix that. Okay, so enough talking. Let's play a game. So everyone, I will ask you 7 questions regarding the content we have covered today. If you answer fast, you get more points. And the 3 fastest among you will get the swipe box shipped for free at their location. To participate to the game, please open a new tab, go to menti.com and use the code shown on screen at the top. And good luck, everyone. Also, maybe a little bit of housekeeping. Do not look at the question on YouTube. There is 2-second delay. And if you want to be as fast as possible, make sure to look, I don't know, either your phone or the new tab, where you do have Menti open. Okay? And with that, I will soon start the quiz. The first question is not a speed question. It's a question because sometimes we have cheaters, we have people using bots. So the first question is kind of a CAPTCHA to avoid any bots. So don't be super surprised if the first question is super easy, okay? That's by design. Okay, all right. I do have 48 people and 65 watching, so I think we have almost everybody. So good luck, everyone, and enjoy the game. So all question give maximum input. Which form do you see on screen? Hey, I warn you, okay? Is it a rectangle, a triangle, a circle, or a beer? Yeah, I know what you think, Mary, but hey, look at that. We had one bot. So we tricked the bot. Okay, we can keep moving. Okay, so now let's get serious. All right? Question number 2. Let's do it. What is Spring Webflux? Is it a reactive application generator? Is it the reactive stack for web Spring Framework? Is it the streaming framework for Spring or the Spring Web TV? Yeah, most of you got it correctly. It was indeed the reactive stack, the one we have seen on the left part of the screen. Good job. So let's see who was the fastest among you all. And whoa, I recognize some names. I see people asking questions in the chat. Yeah, that's great to see. So Arturo was the fastest this time, but Raul and Francisco are pretty close. Bruce only 3 points behind. You know, nothing is done. I think we still have 5 questions to go. All right, okay. Ready? Question number 2. What are the interfaces used by Reactor and Webflux? Completion stage and future, ASIC and SIC, mono and flux, or uranium-235, plutonium-239. You know, Reactor. No. Okay. Yeah, indeed. So the interface used by Reactor was mono and flux. Okay, the two I insisted on at the end. Not all those questions are tricky, but yeah, mono and flux. Async and sync is not relative to drivers at all. All right, this time, ooh. Okay, Arturo again. Taz, Tristan, but Giz was the fastest, and yeah, nothing is done yet. All right. Question number 4. How would you describe Gitpod? Git in Kubernetes, a complete ID platform in the cloud, a distribution of Eclipse, a pod for the Git family to live. Okay, this one was too easy, right? It's indeed an ID in the cloud. Okay, right. Okay. Whoa. Arturo again. Wow. Okay, Tristan, Taz. I think we do have a 3 on the podium. Oh, wow. Kerry is pretty close. Come on, come on. Nothing is done yet. Question 5. So 3 more questions to go, right? Let's go. What is ASTRA DB? A new SQL database? A new SQL database. Apache Cassandra as a service with extra tools. A movie with George Clooney. Yeah, indeed, it was Cassandra and Cassandra as a service, and not a movie with George Clooney, because first of all, Ad Astra is the title of the movie, and it's not George Clooney, it's Brad Pitt, I think. All right. Okay, 2 more questions to go. Oh, Tristan. Yeah. Okay. Arturo, Kerry, Taz, Jez, Francisco. Wow, wow. The competition at its highest. 2 questions. Okay, okay, okay. Let's see. What could be the weak point of asynchronous APIs? Provide back pressure, call back L, blocking calls. Eventually, they never call you back. Yeah, it was my joke. Yeah, yeah. Why asynchronous API cannot really be your friend? Because eventually they will never call you back. No, indeed, the callback else was the good answer. You know, that nice red cloud that I had in my slide. Yeah, it's not easy. Wow, pretty spread answer this time. And last question. Oh, wow. This time, yeah, maybe it was a tricky one. Yeah, don't know. Oh, wow. Everything changed suddenly. Wow. Kerry, GitHub, Francisco, Gropo, R, and Kevin. Wow. Okay. Okay. Yeah, that's nice for those who just got the mistake, but it's also kind of quite a suspense now. You know, it's not like everything is done after 3 questions. All right, this one is serious. Last question, stay focused. What is our recommended approach to build an application with Cassandra? Start with the code, data model, and if you stuck indexes, query data model code, code, allow filtering, code, deploy, fix. Yeah, thank you. Most of you had it correctly indeed. Start with your queries, know what your app is doing, then get your data model, create the table in Cassandra, and only then code. All right, so final leaderboard. Who is our winner for today? Our winners for today. Okay, let's see. All right. Okay, so congratulations to the 3 winners, Kerry, Francisco, and R. Make sure to do a screenshot right now of your screen. You will send an email to jadfryer@datastacks.com. I will show you the email in a minute, and you can watch the recording. But make sure to do a screenshot now because you need it to claim your prize. But congratulations to all the winners. It's not the easy. Some questions are tricky and you were fast. So congratulations. I will let the Menti open just for the feedback. Okay, we are now at the end of the session. I will let the feedback form running and give you a few slides to wrap up, but we are done for today. 2 more minutes and we are done. So first, I told you if you are winners, this is the email to send your screenshots and probably put the date and the title of the workshop. We are doing so many of those. I'm just thinking of Jack, who does have his inbox probably filled. And yeah, we will make sure to get you some swag. So yeah, you're welcome. Second is, as of now, we are running an hackathon, so even more money to get. So 3 months. Each month is the dedicated competition with some ruling. What you ask you to do is the app you like with the theme we propose. Okay, using ASTRA. The idea is really for you to get your hands dirty on ASTRA and do what you like. It's just a theme, nothing imposed. And every month we as a judge, we just the better application submitted. And yeah, so take your chance. Here is the link, and go for it. Discord. So we had the question just before, how to get support after the session. Discord is the way to go. We are there every day of the week, and if you have a question, please ask. Okay, and the session is recorded, and the recordings will be available in 15 minutes at the same link. Okay, so nothing to change. So if you enjoy, and maybe we should have asked that before, but now that we are with us up to the end, and you are pretty engaged, why not subscribing to the channel and giving a like to the video, and make sure to come back next week. I think next week will be an e-commerce application, and yeah, I'm happy to have you up to the end. Hope you enjoy what we did, and see you next time. All right, so yeah, thank you very much, everyone, and have a great one.
Thank you.
Bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Interbeing gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.